So, when I say rational root, I'm talking about what we've been learning, like say x to the 3/4 power. We know that x to the 3/4 power becomes the 4th root of x to the 3rd power, right? That's what I mean by rational root. Rational is just a fancy schmancy word for fractional, for a fraction. A rational number is a number that can be written as a fraction. So rational root, look at it becomes the 4th root of the 3rd power, right? And an equation, you've seen equations way back in Math 1 in junior high. You guys know what an equation is. Let me give you an example. It's any statement in math that has an equal sign and you have stuff on the left and stuff on the right. You're in the world of equations. For instance, 2x equals 10. So rational root equations, I'm talking about equations that are going to have rational roots in them. It's going to get crazy. We're talking about pre-calculus type of equations that we're going to go over right now. But the thing is, they look a lot scarier than they actually are. And what I've taught you thus far already, I've already prepared you for the battle. So all I did is explain the title. We're not even into the lesson yet. I just want to make sure you understand the title. You already know what rational roots are. We've been dealing with that the last week, or last 2 days. And you already know what an equation is. But do you really understand what an equation is? Go ahead and write 2x equals 10 again. I want to talk about the nature of an equation. What's the goal of every equation? When we have an equation, what's the goal? You guys remember from junior high or math 1? What do you want to do? When an equation is thrown at you, what is it you want to do? Solve for x, huh? And the way we solve for x is by getting x alone on one side of the equation. So the equation always has two sides, the left and the right. And we want to get x alone, isolated on one side. Remember, that's junior high. That's way back middle school. And the way we get x by itself is by doing something to both sides. Because an equation is kind of like a balance. It's like a balance beam. In other words, you have a balance beam here? You used to have a balance beam. Dang it. Forget that, it's too important. Watch this. Now we're talking. There we go, this is what I'm talking about. An equation is like this. Whatever you do to one side, you got to do the other. But the thing is, you can do whatever the heck you want to both sides. As long as you do both sides, the equation still stays the equation. Let me demonstrate. So right now I want to go down memory lane before I set you up for the crazy lesson day. We're not even into the lesson yet. I got to just do some background real quick. What do I do to both sides to get x by itself? Divide by 2, because 2 times x, you have to do the opposite times. So x equals 5. Okay, cool. Don't even write that down, just pay attention real quick. Let me go Dodger blue now. Let me rewrite the same equation. Go beyond, what's your favorite number?
5.
Look what I'm going to do. With Gobion's favorite number, I'm going to multiply both sides of the same equation by 5. So I'll have, let's see, 10x on the left equals 50 on the right. The equation's still the equation. It's still the same. I can still solve for x. All I've done to both sides is I multiplied by Gobion's favorite number. 1 second, what's your favorite number? Thanks, Fonseca. Look what I'm going to do. I'm going to subtract Fonseca's favorite number, but I'm going to do it to both sides because I'm thinking of the scale balance. Watch, let's see what happens. So I'm subtracting Fonseca's favorite number, from both sides. All right, what's going to happen on the left? What's 10x minus 3? Thank you, appreciate it. What's 10x minus 3? Thank you. Really? No, that's good.
It's just 10x minus 3.
Right, they're not like terms, huh? So it's a trick question. You can't combine numbers with x's. You have 10 x's, you can't subtract 3 from 10 x's, you just leave it at 10x minus 3. Over here then it's 50. What's 50 minus 3? That I can do. That's 47. All right. All I did is subtract Fonseca's favorite number from both sides of the equation. Solorio, what's your favorite number? I'm going to add Solorio's favorite number now to both sides. Again, you don't have to write this down, just pay attention. We're not even in the lesson yet. But if you want to write it down, it's up to you. Go ahead. All right, so 10x minus 3, now I'm adding 11, so 11 and the negative 3 I can combine. Those are just numbers with numbers. It's 8, huh? So 10x plus 8. And 47 plus 11 is 58. The equation is still the equation. It's still the same equation. All I've done is just first I multiplied by Cobian's number. I subtracted Fonseca's favorite number. Then I added Fonseca's. I can't remember. Yeah, I subtracted Fonseca's and then added Solorio's. Martinez, what's your favorite number? 5. What I'm going to do? I'm going to multiply both sides by Martinez's favorite number. Now trust me, I'm going somewhere with this. Just pay attention. Watch what happens. Right, Valladares? Phone's away right now. Up here. So, Martinez's favorite number, I'm multiplying the left side and I'm multiplying the right side by 5. Let's see. I got 50x plus 5 times 8 is 40. 58 times 5 is I have no clue. 58 times 5, 290. So the point I'm trying to make is that you can do whatever the heck you want to both sides of an equation so long as you do it to both sides. What I'm going to do now is I'm tired of adding and subtracting and multiplying your favorite numbers. I'm just going to I'm going to solve for x. And guess what? It's still going to be 5. Because I'm going to do everything I do, I'm going to do it to both sides of the equation. Phone's away right now, Slodio, you're the man. Let's see, 50x plus 40 equals 290. I'm going to subtract 40 from both sides. Look, I'm doing it to both sides. 290 minus 40, I want to say is 250. Now let's divide both sides by 50. Again, I'm doing it to both sides. X is 5. See? Same thing. The point I'm trying to make in all that, your favorite number, doing it to both sides, is that if I'm dealing with an equation, I got to do the same thing to both sides of the equation. I want to drive that to your skull right now. Now watch this. So on your notes now, I'm going to write opposite operations. Watch this. So on your notes, go to write the square root of 2 to the second power. So when I write the square root, remember automatically there's a 2 here. Unless it's otherwise stated, you always assume it's a 2. So right now, the index of the 2, I'm asking what's the square root of 2 to the second power? Well, it's going to be 2. Because, well, I'm going to let you see the pattern now. Watch this. How about the cube root of 2 to the third power? The cube root of 2 to the third power is just going to be 2. How about the fourth root of 2 to the fourth power?
2.
2. You're starting to see the pattern. I'll do one more. The fifth root of 2 to the fifth power is 2. So what I'm trying to get you to see right now is that the index, if it's the same as the exponent, they cancel each other out, and the answer is just the radicand, the number underneath the radical. If the index of the radical and the exponent are the same, they cancel each other out, they're what we call opposite operations. They undo each other. So squaring undoes square rooting. Cubing undoes cube rooting. Fourthing undoes fourth rooting. And so on and so on and so on and so on. That's the big idea right now before we dive right in. Now we're going to dive into the equations. So I'm setting you up for the kill right now. Okay? Exponents and radicals, they cancel each other out. Right, Beltran? Phone's away right now. We're at the floor. Here's example 1. Go write example 1. There's an equation you've never seen before. I'll bet a lot of money you've never seen an equation that looks like that. I could be wrong though. Go write example 1. We're going to solve for x. Go write that. Solve for x, that means I got to get x by itself. We learned that in junior high school. We just went over that. If an equation is thrown at you, you want to get x alone. All right, I'm looking at this equation. X is right there, and it's to the fifth power. We got to get it alone. So, what should I do first to get x by itself? So the left side of the equation is all this. Here's the right side of the equation. I want to get x by itself on the left. Any ideas? I love it. Whatever I do to one side, remember the scale balance, I do the other. I'm liking it. Bye-bye to that. X to the fifth power is, help. Nice. Phone's away, screen's away. Fonseca, you're the man. I want to get x by itself. I see a fifth power. Help. What do I do? Give you a hint. I'll give you. Go on, what was that?
Don't you gotta do the square root thing with a 5?
Fonseca's on it. I'm gonna fifth root. Remember what we just talked about? Look at opposite operations. Fifth rooting, the opposite of fifth rooting is, no, the opposite of fifth power is fifth rooting. Thank you, Fonseca. Rocking it. Watch this. I'm gonna take the fifth root of the left side, and I'm going to take the fifth root of the right side. Whatever I do to one side, I do to the other. That's the principle of equations that we learned in junior high school and middle school. That's the scale balancing. Whatever you do to one side, you got to do the other, right, Kobian? On the way. Okay. I'm going to turn that off. I hear some music or some garbage. Please turn that off. Thanks. Watch this. Fifth exponent and the fifth root cancel each other out. I got x by itself. Yes. And on the right side, I got the fifth root of negative 32. I'm bad at mental math. Remember, I told you I was a philosophy major. So I can't do quick mathematical computation, so I'm going to rely on my calculator. Fifth root of negative 32. Here we go. Clear this puppy. So it's the nth root button. It's asking for the index. I'm going to put 5. The radicand, negative 32. Rocking and rolling, negative 2. Done. X is negative 30, negative 2. Should it be positive and negative 2? Should it be a positive and a negative, like we did in warm-up? Yeah or no?
No.
Why, Beltran? Why no?
Because, well,
You're right. It's no. Well, why?
because it like evens out with the 5. The 5's like an unknown number,
Nice.
so it's still negative.
Right. So I like the way you're thinking. Not, what's a shorter way of saying what you just said? Someone else? Did someone else say no? Cruz, did you say no? What's your reason? Give me an argument.
I mean,
Just thinking about it?
Positive 2 to the power of 5 wouldn't be a negative
Good.
in the first place.
I like that. You're just thinking about it just with the nature. 2 to the 5th power, positive, it would not be negative 32. Only negative 2 to the 5th power, that's exactly what Beltran was saying. So what I'm trying to get at is the index is odd. Yesterday's notes, odd. You have a positive number, that means you only have one root, one answer. If it's even, and you have positive, then you have 2. So odd is one answer, even is 2 answers. Rocking and rolling. So negative 2 is a solution. We solve for x. So we did it by the 5th power, or the 5th root. We undid the 5th power by the 5th root. Let's try example 2. I'll write this down. Six x to the 3rd power equals negative 6. What do I do first to get x by itself? So I'm thinking junior high school.
Divide by 6.
Gracias. Get that out of here. X to the 3rd power is negative 1. Rocking and rolling. X is not by itself. I got to get rid of that exponent of a 3. Someone besides Fonseca or Cruz, what do I do? Sort it out. Someone, no, not Cruz, not Cruz, not Cruz.
Oh.
Someone besides Cruz or Fonseca, what do I do to both sides now? Whatever I do to one side, I got to do the other. But what do I do here?
The root, the thing.
Thank you. What kind of root though? There's a lot of roots. Which one?
I don't know.
Square root would be a 2 index.
A regular root.
The cube root on. 3 is cube root. Nice, Elodio. Both sides, cube root. Look at this. That undoes the exponent. X is by itself. Yay, that's what we want. Cube root of negative 1. I could do that in my head. Negative 1 times negative 1 times negative 1 is going to be negative 1. So it's going to be negative 1. Positive 1 times positive 1 times positive 1 is not going to be negative 1. Rocking and rolling. Done. Couple more and we're done. Questions so far? I'm gonna go a little faster now. Seems like you guys are getting it, I think. Could be wrong, but. Example 3. Put this one over there. Example 3. Excuse me. All right, let's get rid of the 100 first by subtracting both sides by 100. You always wanna start getting rid of the numbers farthest from the variable first. 100 is farther away from the variable than negative 1/10. So I'm gonna get rid of the 100 first. By subtracting both sides by 100. Watch this. Negative 1/10 x to the third power equals negative 100. Some good coffee there, shoot. How do I get rid of that negative 1/10? Help, please.
Multiply by 10.
Nice. By a negative 10 now.
Yeah.
So I can do two things. Thank you, Fonseca. I can divide by negative 1/10 on both sides. Look at. Because this is negative 1/10 times x. If I divide by negative 1/10, it's gone. But dividing by negative 1/10 is the same as multiplying by negative 10 over 1. If you remember from junior high school, when you divide by a fraction, it's multiplied by the reciprocal. I don't know if you remember that, but yeah. So Fonseca's right. Just multiply by negative 10 to get rid of that. So negative 100 divided by negative 1/10 is the same as negative 100 times negative 10. So times negative 10. The reciprocal, it becomes negative 10 over 1, right? Trust you guys got that? Stop me if I'm going too fast. Just dividing by both sides by negative 1/10, which is the same as multiplying by negative 10. All right, x to the third power is negative times negative. I want to say is a positive. My coffee has kicked in. That's going to be a positive 1,000, huh? Nice. I turn it off just so I have it work. I appreciate you doing that. Someone besides Solorio, Fonseca, or Cruz, what do I do to both sides now? I heard of somebody. Squares with a 2 index. You're there. You're there.
Q?
Cube root it. By to that, x is going to equal to, we're going to have one root because this is odd. Cube root of 1,000, I want to say is 10. Yeah. Done. If you don't believe me, use your own calculator. Last example and we're done. You guys are doing good. You guys are doing awesome. Let's do this one instead. Oh, we did that one already, yeah. Let's do this one. Yeah. This is example 4? Yeah, okay. Solve for x. This one's a little tricky because you have that parenthesis to the 4th power. You have a parenthesis to the 4th power. Don't write this down, but what that really means, this really means this, watch. That's what it means. Don't write this down, but this means that. X plus 5 times x plus 5 times x plus 5 times x plus 5. We're going to be there all day multiplying a bunch of, doing the FOIL method, and that'll be madness. So here's what we're gonna do. Here's what we're gonna do. Let's first get rid of that 2. Let's get rid of that 2 first. And let's isolate just what's being raised to the 4th power. In other words, I'm gonna make the parenthesis only on, I'm gonna isolate it, get it by itself on the left side, because that's the only thing being raised to the 4th power, not the 2. So let me get rid of that 2. How would I get rid of that 2? Anybody?
Divide by 2.
Gracias. Rocking and rolling. Watch this. Whatever I do to one side, I could do the other. Remember when we talked about the scale balance? I was doing that with your favorite numbers. I was doing all kinds of stuff to both sides with your favorite numbers. Watch this. Gone. X plus 5 to the 4th help.
64.
Gracias. I'm bad with mental math. Should have studied math instead of philosophy. No way. Take that back. No way. Philosophy was the best. I got 4th power. Let's get rid of that 4th power. How would I get rid of it, Mesa? How would I get rid of the next one and 4th? Don't worry if you don't know. I want to get rid of that. Don't worry about it. Violadas can save the day. How would I get rid of that 4th power? Don't worry about it, you don't know. Huh?
I don't know.
Got you. Guzman's gonna save the day.
Um,
How do you get rid of that 4th power?
the square root of,
Nice. But it says square, it's 4th root. Good. You're on the right track. So look, watch this. 4th root on the left, 4th root on the right, and we're rocking and rolling. We're going to be careful now, because remember, this is an even index, so I know I'm going to have 2 answers right there. Careful. Careful, careful, careful. So, on the right side, I'm going to have a positive and negative. Is it 4? 4 times 4 is 16 times 4? No. 3? Is it 2? What's the 4th root of 64? Let's see. 4th root, I thought it had a 64. Nope, it's not, so I'm gonna have to approximate. Excuse me, 2.8, I'm gonna go to the second decimal, 2.83. But I'm a positive and negative 2.83. Look at it. A positive answer, negative answer, because again, that index is even, careful. And on the left side, look what I got. On the left side, I have x plus 5. X is almost by itself. I still got the 5. What do I do to both sides? Thank you. But careful now, watch. Divide by that, x is equal, now watch. I got a negative 2.83 minus 5, and I got a positive 2.83 minus 5. I'm going to have 2 answers, because remember, I got the positive and negative 2.83. In other words, 2.83 minus 5 is going to be one answer, and negative 2.83 minus 5 is going to be your second answer. We got to get it right. We got to get both answers. Let's see. Help. One more time.
2.17.
Positive or negative? Nice. 2.83 minus 5.0. Yeah. 2.7 one more time, or 2 point what?
2.17.
Gracias. And that's one solution. The other one's going to be negative 7.83 if my coffee is kicked in. Negative plus more negative, right? Cause negative 2.83 minus 5 is the same as negative 2.3 plus negative 5. Line up the decimals, just add those puppies. I think I'm right, right? Or no? Nice.